is going to be next is waste to energy in the paper industry. An example of a new plant by Martin Simmler of Norske SKOG. And I can see your screen.
Okay, is it working?
Yeah, try to go to the next slide, but this is a PDF, so that's probably easier. Wissam, you need to mute yourself.
Yes.
Yeah, super, works.
Sorry, I have to jump back. I think I took the PDF now.
This is good, huh? It looks good.
Yeah, but
the wrong PDF, maybe.
I made a short-term change due to the
okay, an improvement
discussion before.
Yeah. Okay. This is
This is the advantage to be the last presenter, no?
Yes,
exactly. You can adapt.
I'm very thankful here to be the last presenter today, so I can incorporate some additional information, replying to the three speakers before me. So my name is Martin Simmler. I'm here at the Norske SKOG paper mill in Austria, in Bruck an der Mur, the head of energy, environment, and sustainability. So I want to talk or show you the example of our new waste to energy boiler, which we started up 2 years ago. First of all, who is Norske SKOG and who is the paper mill? Norske SKOG is a Norwegian company listed at the Oslo Stock Exchange with 5 paper mills in 4 different countries, with a staff around 2,000 employees. We are producing publication papers, newsprint and magazine paper, and since 2 years now, we are also in the business of packaging paper based on recycled fiber. Sustainability is key to our business since our key raw material always comes from wood. So we are using the renewable fiber as raw material directly from wood or in the recycling process from recovered paper. So a picture of our Bruck mill, and here you can already see some very important points. I will come back later on. So it's placed in the middle of the city, and it's an industrial site located very close to the direct neighbors. And this is important for fulfilling all environmental regulations to be able to operate such a plant in the middle of the city. And also such a plant has to be there where the heat is needed to reach a very high efficiency, also providing district heating for the city. So our site has a very long history. We are making paper for more than 140 years at our site. The 2 important steps was the build of paper machine 3 in the 50s, producing newsprint for almost 70 years, and the installation of paper machine 4, producing publication paper called LWC. Since 1996, we are owned by Norske SKOG, and in the last 2 years, we were lucky to have 2 big investments at our site. This is on one hand the installation of the waste to energy boiler to reduce the use of fossil fuels, and on the other hand, the rebuild of 1 paper machine from newsprint to packaging paper based on recycled fiber. So this picture shows it's a simplified picture that should demonstrate how sustainable and circular the paper production is. So here we see the 2 big projects that we had. On one hand, we call it the project boiler K9. We just number our boilers, which is now the waste to energy boiler based mainly on RDF fuel, paper rejects and sludge. This is replacing the use of natural gas in the mill. We were one of the biggest users of natural gas in Styria with almost 1 terawatt hour. We could reduce this dramatically by now using the heat from the waste to energy plant. all the heat is used for running the paper mill, running the process where heat and power is needed at the same time. So in a combined in a heat and power plant, you generate heat and power at the same time, and you use it at the same time in the production process. The raw material for the packaging paper, the production of packaging paper is the second big project, gives paper rejects. The paper collected and used as raw material for making the new packaging paper contains a lot of contaminants, which is generally called paper rejects. This can be up to 5 to 10% of the collected recycled fiber. And this these paper rejects we can directly use at our site in this new boiler to generate the energy that we need. Also, this recycling process gives a wastewater stream with a high contamination. This is treated in an anaerobic water treatment, producing biogas, which is also used in that new waste-to-energy boiler. Coming back to what Mr. Grech said in the very beginning, that's why I included this additional slide. I took this picture from CWEB. The landfill ban is the key to reach a high recycling rate, to reach a good waste industry. Here we see the member states of the European Union. On the left side, you see those countries who have a very well-established recycling industry with almost nothing going untreated to a landfill. But we are not playing on the same level within Europe. You just have to go south or east of Austria, and the situation is completely different, although we are all have the same European legislation. So I think all what you see red here on that slide is where the action needs to be done, that the material, the waste does not go to landfill, it has to go to recycling, and it has to go to thermal treatment as part of the waste hierarchy. So we have a long history at our site for more than 40 years using our own residues, waste materials in our process, providing heat, but also providing, recycling raw materials. For more than 40 years, we run a fluidized bed boiler with burning our sludge from our wastewater treatment plant and from the recycling of paper, which has a very high content of minerals. And we also use here the bark that we get from the fresh fiber from the wood that we use for the paper production. The ash that this boiler gives was already used in the cement mills for many years, and now for 5 years this ash is a certified product. It can be used as a replacement of cement for applications like ground stabilization. So the technology used here is a fluidized bed incineration. That's a big difference to other incineration technologies. I want to briefly explain this. There is a big simple graph showing the key of the fluidized bed. You have a sand bed, roughly 0.5 meter high, and you blow the combustion air from the bottom through that sand. And the more air you blow, this sand starts moving, it starts bubbling. There comes the name from, bubbling fluidized bed. And the incineration takes place there. The sand is hot, 800, 850 degrees. And from the side, you add the fuel to this sand bed. Part of the incineration takes place in the sand bed, part in the air in the room above it. The big advantage is that you have a very good combustion, a very complete combustion, and you can use fuels with very low heating values, which cannot be incinerated in other technologies like a grate fire. The residues from paper recycling, the sludge from paper recycling has a heating value of 4 to 5 megajoule only. Also, the bark is very wet and also has a very low heating value. And we will come back to this later, because we see here all material that is bigger than roughly 2 millimeter, we have to remove from that sand bed and can later go to recycling. I will come back to that later. But the fluidized bed technology needs the treatment of the fuel before the incineration. That's the big difference to a great incineration, where you can just put everything inside. So therefore, the fluidized bed technology fits way better into the waste hierarchy, and also helps to reach the recycling goals, because the fuel has to be treated, sorted, and shredded before it goes to the incineration. And so you can take out the valuable materials before the incineration. And even after that incineration, the ash is way better prepared for the recycling process. So in our new plant, in our new boiler, we use the same technology, since we have a good experience here. Here we have an aerial view showing the paper mill, and in the front area there is the fuel storage area. We receive all the RDF fuels and paper rejects and sludge by train or by truck. And we have a storage of roughly 7 to 10 days of fuel demand for our boiler. And on the left side of the picture, there is the new facility, the waste to energy boiler with the flue gas treatment. It's a very dense industrial site, and here you can see how on a very small footprint this can be set up at the industrial site. So what were the key facts why we did this? The main focus was to reduce our gas consumption with a combined cyclic power plant with a gas turbine and the HOSG and the steam turbine. We made all the power and all the heat we need in the mill at the same time. But we were, as I said, a very big consumer of natural gas, up to 1 terawatt hour. And so by now we get most of the heat that we need for the production of paper from that new boiler. And therefore we could reduce the use of natural gas by 75%, and in the same time reducing our CO2 emission from the fossil fuels by the same ratio. It is also a diversification for our business model, and it's the capacity of that plant is roughly 160,000 tons of wastewater treatment, sludge, paper rejects, and RDF fuel. And it's the design of the plant is done in that way that all new regulations from the new BAT document for waste incineration are included in that plant, so it's future-proof. For most of the emission levels to air, we have values lower than 1/10 of the emission limits of the newer emission limits. And it's placed in an industrial site using a lot of existing infrastructure. So it's not on a green field somewhere out there where nobody sees it. It is at the site where the heat and the power is needed at the same time. And that's the key to a high efficiency. So we see here a technical drawing with the main parameters. So we have a thermal heat of roughly 50 megawatt. This gives about 65 tons of high pressure steam, where we can make power at the steam turbine and then use the low pressure steam to supply the paper mill. And the design fuels is paper rejects, sludge from wastewater treatment plants, fiber sludge from paper recycling, and RDF fuel. And we see here on when we go from the left side to the right side. On the left side is fuel silos to provide the kind of continuous feeding of the fuel to the boiler. The blue area is the incineration area itself. At the bottom there is the sand bed with roughly 0.5 meter high the sand bed, and the combustion air goes through that sand bed and the sand starts moving. And you add the fuel to that sand bed, and there the combustion takes place. Here in the combustion area, you have around 800. You are making sure to fulfill the 850 degree 2 second criteria. And all the boiler walls are made as steam pipes. So the steam evaporation takes place in all the boiler walls. And in an empty pass, it goes down, and in the third pass there is the superheater placed to reach the steam temperatures. After this we remove already part of the biggest part of the fly ash, which goes with the exhaust gas. And the big advantage is that we remove the ash here at the temperature of roughly 400 degrees, so it is of a good quality with low contaminants in it. And it should be suitable in the future as a secondary raw material. After this, there is the eco for the feed water heating, and then the boiler more or less itself is finished, and then the rest of the plant is the flue gas cleaning. We use here a dry system. We add activated lime and activated carbon and hydrated lime to the flue gas, and remove all the acid contaminants together with that at the backhouse filter. After the backhouse filter, we already fulfill all emission levels except the NOx, but we added another step of flue gas cleaning and heat recovery. That's a special point in our plant, that we here have a flue gas condensation, not only condensing for further cleaning of the flue gases, but for recovering the heat out of it. So we get, with this 50 megawatt plant, we get up to 10 megawatt of low temperature heat additionally, which we can use for district heating and heating up process water for our own production processes. After this flue gas condensation, it's heated up again to for an SCR catalyst for the NOx reduction. So the overall plant efficiency is very high. Taking also into the boiler efficiency itself is 90%, and taking also into account the recovered heat from the flue gas condensation, we are technically above 100% efficiency. So what are the fuels that we are using? Our own rejects and sludge from the paper production, the fiber sludge, which contains a lot of the fibers that cannot be used for making paper again, and the mineral fillers from the recycling of paper, and also mechanically dewatered sludge from municipal wastewater treatment plants. The paper rejects are the fuels that we have on our own in our mill from the recycling of paper, what cannot be used, what is not fiber, what is not dissolved as fiber to make new paper out of it, goes to the rejects. You see how it looks like, and this is also a big share of our own paper rejects, is quite a big share of the fuels that we need. And the main share are the refuse-derived fuels. But here it's very important to mention that we are focusing on different RDF qualities than the cement industry. We are not competing to the cement industry. We are the complementary part of it, taking care about the whole thing that comes out of the sorting plant. The cement industry needs special qualities with very low chlorine contents and higher heating values. What does not fulfill these criteria, this is suitable for our boiler. We are not focusing on the high heating values. We are more focusing on the lower heating values, and we are more tolerant to chlorine than a cement mill. So this is showing the fuel storage, as I said, roughly 10 days of operation, and we also have included our own fuel preparation, that we can take fuels which are not ready prepared for the fluidized bed. The fluidized bed needs a particle size of roughly below 100 millimeter in 2 dimensions. This is what is needed. And a very important part for us is our quality process for the fuels. I think for waste to energy plant, we are also making new ways here. Cement industry is very ahead here, but waste to energy did not have this before, and we here have a full quality process, starting with the definitions of the fuel quality to our customer. This is presented in a contract to the customer. We check the fuel quality. We check the processes of our customers, of the sorting plants, what processes do they have? Are they capable to prepare the fuels in the way that we need it? We have an income quality check, which we can do partly online. All the fuels that we receive pass on a conveyor belt and a near infrared sensor, where we have a very fast and good detection of the quality. So we have a very good number of heating value, moisture content, and chlorine content of the fuel that we get. So we can, as soon as the truck unloads, some minutes later, the fuel passes that sensor, and then we can have a very quick feedback, a very good information what is in the truck. So even before a truck leaves the mill, we have the first quality information. We have our own quality lab, where with an XRF, we can have our own analysis. So we are also very quick with the lab and analysis here. The boiler operation itself also gives a feedback from moisture content, heating value, and also the chlorine measurement in the raw gas gives us a number. And now we are running that process that all customers get a weekly quality feedback, that they really know what they are delivering us, and we know what they deliver to us, that we have a very fast way to react here. Quality is key for us because the chlorine is, we can tolerate a higher chlorine content than the cement industry, but we have to protect our boiler. The higher the chlorine content, the more risk of corrosion in the boiler is, which will end up at way higher maintenance costs at the end. This is what we want to avoid. Also, a very important part when you enter the RDF business is the fire protection. As a paper mill, we are used to handle with combustible materials, but RDF plant and fuel storage for RDF is a completely different level. We have incorporated the latest knowledge from fire protection in our project. We all know that a lot of recycling companies face that problem of batteries and accus in the waste, and therefore there is a high risk of fire. We have incorporated all this, including our own fire brigade that we have in the mill, but also in the design of the fuel storage extinguishing system and so on. One word to the flue gas cleaning. As I said, in the cyclone, we remove most of the fly ash at 400 degrees, so it has quite a good quality. We have the dry cleaning system with the activated carbon and the hydrated lime. This is removing the contaminants and the fly ash from the backhouse filter is the real sink of contaminants. Additionally, we have that scrubber system as heat recovery and also as a further cleaning. And the last step is the catalyst for reducing the NOx. Important is to know that waste to energy under the Abfallverbrennungsverordnung in Austria has way stricter emission limits than other boilers and the cement mill. And with that proven technology, it's easy to reach that low numbers. And as I already said, for most of the contaminants, we reach numbers in normal operation at 1/10 of the emission limit. So what is the residual of this waste to energy boiler? It is the bottom ash. Everything you put into that sand bed, that where the material is burned, that's bigger than 2 millimeters, is removed with the sand. The sand is screened. The sand goes back to the boiler. It's used there, and everything bigger goes out. There, all the metals, stones, glass, ceramics come out, and this material is already going to the recycling. So it's also R5. So we can, this is roughly or almost 50% of the whole ash content comes out here. So we contribute also to the recycling with preparing that bottom ash that way that it can be recycled. That's also a big difference to grate-fired incineration, where you have a slag at the end, which is not so suitable for recycling. Also a big part is the cyclone ash, also roughly 50%. Today, it has to be brought to a landfill, but this is also our goal, that this can be used as a secondary raw material. And I think this is one point where we want to work together with the cement industry. This is a quality proven, a very constant quality that we get here. And a big difference also to the use of RDF in the cement industry, where all the material goes to the product. The waste to energy is a sink for contaminants. It is just a small amount. It is 5 to 10% of all the ash. This is the ash that we move at the backhouse field, and all the contaminants are in there. So we reduce the big amount of waste to a very, very small amount of filter ash. This is hazardous, and this is the sink for the contaminants. So we move contaminants out of the system, and it is brought to a landfill, solidified at the landfill under the strict regulations, and therefore no harm for the environment. A short view on the energy, how the energy balance of the mill looks like. On the upper side, you see how the mill looked before. So we made roughly all the power that the mill needed with the combined cycle power plant, with the gas turbine and the steam turbine. But therefore, we had to use roughly 1,000 gigawatt hours of natural gas. The smaller greener amount you see at the top, this is the fuel from the old fluidized bed boiler. This is the own sludge and the own bark that we have. So, and on the lower hand, you see how the situation looks now. We reduced the use of natural gas by 60 to 70%. Also, the emission from fossil fuel in the same ratio. But therefore, we produce less power on our own, since the gas turbine is not running or not running all the time. But therefore, we purchase power, which is also a way to the decarbonization, taking into account that the electricity will be decarbonized with the higher share of renewable energy coming to the grid. And the fuels, we could reduce the share of natural gas, we could reduce quite big. And therefore, we have now the share of the fuels from the RDF and the paper rejects providing the heat that we need. So it takes some time to realize such a project. it was almost 6 years from the first project ideas to the final startup. We made a full environmental impact study for that project, and which took about 2 to 3 years, and then it was a very fast process from the final authority approval, our investment decision by our company, and the erection itself was roughly 2 years from setting the groundstone to the startup of the boiler. And no one could think that our startup will be directly in the middle of the energy crisis in spring of 2022. So providing a big reduction of use of natural gas, we had our Minister for Climate Action here at the opening of our new waste-to-energy plant.